Hello students, in our previous class we learned about quadratic equation. That means its definition, its general form, and then the procedure of solving a quadratic equation. And there were three procedures. In the first procedure we have to solve a quadratic equation by middle term factorization. Okay. And in the second procedure we have to solve a quadratic equation by following the method of completing squares, and in the third procedure we have to solve a quadratic equation by following a formula which is known as Srizaracharyya's formula. Okay, so now we will learn how we can solve a quadratic equation by following the method of completing squares. Okay, so this was the quadratic equation, where solving this equation by middle term factorization we get these two solutions, that is x equals to -2 and x equals to -3. Now we will solve this quadratic equation by following the method of completing squares. Method 2 or procedure 2, that is by following the method of completing squares. Given quadratic equation is 3x square plus 7x plus 2 equals to 0. Okay. So first of all we have to follow this quadratic term. So here the quadratic term is, that means the square term is 3x squared. The coefficient of this square term is 3. So first of all we have to remove this coefficient. Okay. So to remove this coefficient 3, we have to multiply both sides of this equation by 1 by 3. Okay. Multiplying both sides of, this is equation 1, multiplying both sides of 1 by 1 by 3, we get 1 by 3 whole into 3x square plus 7x plus 2 equals to 0. Because 0 into 1 by 3 will give 0, that is why we write only 0. 1 by 3 into 3x square plus 1 by 3 into 7x plus 1 by 3 into 2 equals to 0. This implies, cancelling these 3, we get x square plus 7x by 3 plus 2 by 3 equals to 0. Okay. Now we have to compare this thing with a square plus 2ab. That means we have to compare this x square with a square and this linear term 7x by 3 with 2ab. Comparing x square with a square and 7x by 3 with 2ab, we get x equals to a and 2ab equals to 7x by 3. Okay. Now, our aim is to create this identity. That means a square plus 2ab plus b square equals to a plus b whole square. Okay. Now, our aim is to convert this thing into this identity, that is a square plus 2ab plus b square equals to a plus b whole square. That is why first of all we have to bring these 2 in the right hand side. Since 2 is in multiplied form in the left hand side, when this 2 goes in the right hand side, then this will be in divide form with 7x by 3. Thus we get ab is equals to 7x by 3 into 2. This implies AB equals to 7x by 6. This implies AB equals to x into 7 by 6. So this implies A equals to x and B equals to 7 by 6. Okay. So we can write this as x square plus 2 into x into 7 by 6. Okay. Now, to make this formula, here we have to write plus b square, and here b is 7 by 6. That is why we can write plus 7 by 6 whole square. Since there is no 7 by 6 whole square, that is why to balance the 7 by 6 whole square, we have to write here minus 7 by 6 whole square, and then we have to write the rest of the term, that is plus 2 by 3. Okay, then equals to 0. So now this thing is similar with the form a square plus 2ab plus b square. That is why we can write this as x plus 7 by 6 whole square minus 7 by 6 whole square means 49 by 36 plus 2 by 3 equals to 0. Okay. Minus 49 by 36 plus 2 by 3. We can subtract these terms by following the method of subtraction of fractions. The LCM of these denominators, that is 36 and 3, is 36. That is why in the numerator minus 49 plus 3 12 is 36, 12 2 is 24. This will give minus 25 by 36. So that is why we can write x plus 7 by 6 whole square minus 25 by 36 equals to 0. Now x plus 7 by 6 whole square is equals to 25 by 36. This form, that is x plus 7 by 6 whole square minus 25 by 36, this is known as the form of completing squares. That means here the quadratic term as well as the linear term get a special shape, that is the shape of a square plus 2ab plus b square equals to a plus b whole square. Okay. So this form is known as the form of completing squares, because here the linear term, here the quadratic term as well as the linear term, both will get this shape a plus b whole square. Okay. Now, if we remove square from left hand side, then we have to write plus minus on the right hand side and then square root of this right hand side value. Thus we get x plus 7 by 6 is equals to plus minus root over of 25 by 36. Why we have to give plus minus? Because plus 4 whole square is 16 and minus 4 whole square is also 16. That is why when we want to remove square from left hand side, we have to give plus minus in the right hand side and then square root of the right hand side number. This will give x plus 7 by 6 equals to plus minus square root of 25 is 5 and square root of 36 is 6. Okay. Case 1. Taking positive. X plus 7 by 6 equals to 5 by 6. This implies x equals to 5 by 6 minus 7 by 6. This implies x equals to 6 becomes the LCM and in the numerator 5 minus 7. This implies x equals to minus 2 by 6. Cancelling 2 and 6, we get x equals to minus 1 by 3. Taking case 2. Taking negative, we get x plus 7 by 6 equals to minus 5 by 6. This implies x equals to minus 5 by 6 minus 7 by 6. This implies x equals to 6 becomes the LCM and in the numerator minus 5 minus 7. This implies x equals to minus 12 by 6. 12 6 the 6 2 the 12. This implies x equals to minus 2. So therefore we get x equals to minus 1 by 3 and minus 2. This is our required solution. This solution is same with the solution of this equation when we solve this equation by the method of factorization. Okay, so this is the way by which we can solve a quadratic equation by following the method of completing squares. Okay. In method 3, we will solve a quadratic equation by following Caesar-Arrhenius formula. Okay. So, to solve a quadratic equation by following Caesar-Arrhenius formula, first of all, we have to derive that formula. That means we have to know what is Caesar-Arrhenius formula is. Okay. Or what Caesar-Arrhenius formula represents. If ax squared plus bx plus c equals to 0 represents a quadratic equation where a not equals to 0, then to remove this a from this square term, we have to multiply both sides of this quadratic equation by 1 by a. So, to remove this coefficient of the square term a, we have to multiply both sides of this quadratic equation by 1 by a. So, after multiplying both sides of this equation by 1 by a, we get 1 by a into this is equals to 0, because 1 by a into 0 means 0. Multiplying both sides by 1 by a. After multiplication, we get x squared plus bx by a plus c by a equals to 0. Now, we have to compare this x square with a square and this term bx by a with a, or we can write this as comparing x square with p square and bx by a with 2pq. We get x equals to p and bx by a equals to 2pq, or two pq equals to bx by a. Okay. Here our aim is to convert these terms x square plus bx by a with p square plus 2pq. Okay. That is why we here x square is similar with p square and bx by a with similar with 2pq. This imply pq equals to bx by 2a, because when these 2 goes in the right hand side, then this will be in divide form. That is why pq equals to bx by 2a. This imply pq equals to x into b by 2a. So this imply q equals to b by 2a. Okay. So when we compare this x square plus bx by a with x square plus 2pq, with p square plus 2pq, then we get x equals to p and q is equals to b by 2a. Then to complete this formula, we have to write here q square. Okay, that is why we can arrange this as x square plus 2 into x into b by 2a plus b by 2a whole square. Okay, so this is similar with this form p square plus 2pq plus q square. Since there is no b by 2a whole square, that is why to balance this we have to write minus b by 2a whole square and then rest of the term plus c by a equals to 0. Okay. So p square plus 2pq plus q square is equals to p plus q whole square. That is why we can write this thing as x plus b by 2a whole square minus b square by 4a square plus c by a equals to 0. Okay. This implies x square plus b by 2a whole square is equals to b square by 4a square minus c by a. We bring this rest of the terms in the right hand side. This implies x plus b by 2a whole square is equals to, here the LCM of the denominators 4a square and a is 4a square. LCM of 4a square and a is 4a square. So in the right hand side LCM of the denominators is 4a square and then in the numerator b square minus this 4a square by this a. 4a square by a will give 4a. 4a into c will give 4ac. That is why in the numerator b square minus 4ac. This implies x plus b by 2a whole square is equals to plus minus root over of b square minus 4ac whole divided by 4a square. Okay. When we remove this square from left hand side, then we have to write plus minus and then root over of the right hand side value. Okay, because same as previous, plus 4 whole square is 16, minus 4 whole square is also 16. That is why we can write 16 as plus minus 4 whole square. Okay, that is why x plus b by 2a whole square is equals to b square minus 4ac by 4a square imply x plus b by 2a equals to plus minus root over of b square minus 4ac whole divided by 4a square. This will give x plus b by 2a equals to plus minus root over of b square minus 4ac by root over of 4a square means 2a. This implies x equals to minus b by 2a plus minus root over of b square minus 4ac whole divided by 2a. So x equals to minus b by 2a plus minus root over of b square minus 4ac whole divided by 2a. This implies x equals to, denominators are same, that is why we can write in the denominator 2a and in the numerator minus b plus minus root over of b square minus 4ac. This is known as Sridhar Acharya's formula. Okay, that means if ax square plus bx plus c equals to 0 represents a quadratic equation where a not equals to 0, then x is equals to minus b plus minus root over of b square minus 4ac whole divided by 2a. This is known as Sridhar Acharya's formula. Okay, so this is the derivation of this Sridhar Acharya's formula. Okay. So if ax square plus bx plus c equals to 0, where a not equals to 0 represents a quadratic equation, then by Sridhar Acharya's formula we have x equals to minus b plus minus root over of b square minus 4ac whole divided by 2a. Okay. Now applying this formula we will solve this equation. Okay. Comparing 3x squared plus 7x plus 2 equals to 0 with the general form of quadratic equation ax squared plus bx plus c equals to 0, we get a equals to 3, b equals to 7, c equals to 2. Therefore, by Sridhar Acharya's formula, x equals to minus b plus minus root over of b square minus 4ac whole divided by 2a, we get x equals to minus 7 plus minus root over of 7 squared minus 4 into 3 into 2 whole divided by 2 into 3. This implies x equals to minus 7 plus minus root over of 49 minus 4 3 is 12 to the 24 whole divided by 6. This implies x equals to minus 7 plus minus root over of 25 whole divided by 6. This implies x equals to minus 7 plus minus 5 whole divided by 6. Okay. Case 1. Taking positive. X equals to minus 7 plus 5 whole divided by 6. Imply x equals to minus 2 by 6. Cancelling these 2 and 6, we get 1 by 3. That means x equals to minus 1 by 3. Case 2. Taking negative, we get x equals to minus 7 minus 5 whole divided by 6. This implies x equals to minus 12 by 6. Cancelling these 12 and 6, we get x equals to minus 2. So, therefore, the required solution is x equals to minus 1 by 3 and minus 2. So, this solution is same with this solution. Okay. So, this is the way by which we can solve a quadratic equation by following Sridhar-Acharya's formula. Okay. So, this is the way by which we can solve a quadratic equation by following these three procedures or method. That means by the method of factorization, that means by the method of, we can say, middle term factorization. Okay. In method 2 or procedure 2, by following the method of completing squares, and in procedure 3 by following the method, by following the formula of Sridhar-Acharya. Okay. So, we have to remember all of these procedures very carefully when we want to solve a quadratic equation. Okay. In our next class, we will learn how we can find the nature of roots of a quadratic equation. Okay.